essay 5.6 differentiation rules. So in this video, what we are going to go over is these core principles in calculus. So far we talked about the power rules, right? Power rule is we discussed in the topic 5.3 or the rules of the polynomials is this one, right? So what you're going to go over today are the one that involves the Euler's number, E, natural log, and the sine, cosine, and tangent. So your formula booklet, so I'm referring to that IB mathematics formula booklet, right? Has these formulas in there, so they're in formula booklet. However, the one that involves the tangent is not in your formula booklet. So I suggest that you memorize this last one, okay? Then let's talk about this one x that involves the Euler's number, right? The one that involves Euler's number is a little bit different, or let's say it's a little bit different from the other differentiation rules. So when we have function f of x, if it is equal to e to the power of x, that when you differentiate this function, it becomes, or the stays exactly same. Okay. However, if we say there's a function g of x that equals e to the power of n times x, because the n that we have here is a number, right? When you differentiate this is same as g of x equals to n times e to the power of n times x. Okay, so it kind of uses the concept of the power rule there too. Then example number 1, let's try to apply this concept into a questions. So we need to find the slope of the tangent of the y equals sine x at x equals to pi over 2. So I'm doing the example 1, right? So slope of the tangent, we have to identify the derivative of the function first, right? So we need to find y prime in this case. So dy over dx or y prime is same as, since we have y equals sine x, this becomes the cosine x according to the rules, right? So this y prime is same as cosine x, and we need to find the slope at point x equals pi over 2, right? So we're going to substitute x equals pi over 2 into your x value. As your x value, then we have y prime equals to cosine pi over 2. Then your y prime value is equal to 0 according to the unit circle, right? So unit circle, we have pi over 2, which is the 90 degree, and then that means our cosine value is actually same as this point here, right? So in this point, we have the cosine value equals to 0 and the sine value equals to 1. So we know that the cosine pi over 2 is equal to 0. Also, it is possible to represent answer as in this form. So we can say, so y equals sine x, which is our original equation, has a slope of 0 at that point as our answer. Okay. Okay, then let's talk about the power constant and sum rule. So we actually already discussed this rule with the section 5.3. Okay, the correct name of that derivative of polynomials rule is the power constant and sum rule. But that's not the important thing to remember, right? It's the name doesn't matter. What we need to know is like how to solve this question, right? So in your formula booklet, the formula for this rule is presented in this way. However, we already know that this means if we have x to the power of n, then this is equals to n times x to the power of n minus 1, right? This is what this formula means, right? So if this is our function, I mean, just for your information, this is our differentiated form, right? Okay, then let's do example number 2. So we just simply differentiate the function f of x, right? So we take the power up to the front, right? So it becomes 2 over 3 here times x to the power of 2 over 3, and we subtract minus 1, and the plus 3 becomes plus 0, right? It disappears. So this is same as 10 times x to the power of negative 1 over 3. Okay, and we're going to leave our answer in this format because we don't like to have the radicals as our answer in denominator in our answer, right? IB, remember that IB doesn't like the denominator in their IB doesn't like their answers to have the radicals in denominator. So this is our final answer. Okay. Then let's try example 3. So we need to differentiate the function 5 times cosine x, right? So we said it's a dy over dx. We need to find dy over dx. So we know that function y is equal to 5 times cosine x. And we also know that from your formula booklet that when we differentiate the cosine x, it becomes minus sine x. Okay, so we can say dy over dx is same as 5 times minus sine x. So this is same as minus 5 times sine x. Example number 4. Okay, for this question, we know that there's a e to the power of x and the natural log x, right? So according to your formula booklet again, we know that when we differentiate the e to the power of x, it becomes, or it stays same. When you differentiate the natural log, it becomes 1 over x. If you want to try this question first, and then just stop the video and try the question, and then start again. But this is how you should solve this question. Okay, so since we are trying to find the g prime x, derivative of g of x, we can say 4 times e to the power of x stays same when you differentiate it. However, natural log becomes 1 over x. So the answer is 4 times e to the power of x minus 1 over 2x. Okay. Then let's talk about the product rule. So product rule is very useful when we have one function multiplied to another function. Okay. So once again, the product rule is very useful when you see or when you need to talk about the product of the two functions. Okay, simply we can say if the one function f of x is multiplied to another one like g of x, then we have to find the derivative of the f of x and g of x separated, and then we have to recombine them. Okay, in this way. This formula is presented in this format in your formula booklet. Okay, but so they're actually same thing, right? These two are actually same thing, just uses the different letter. So for example, if you say, or if we say there is two, if there's a two functions multiplied, like let's say we have function y, and if we say there's a x squared multiplied into 3x like this. I know this doesn't really make sense. However, we're going to present this function in this way first, just to practice the formula. And we say if this is equal to u, if this is equal to v, we have to find derivative of the u first, which is the 2x. And the u prime is actually same as du over dx, right? I don't have to repeat that, right? And the v is same as 3x. Then dv over dx or dv prime is same as 3. Then we now have to recombine this. U times dv over dx plus v times du over dx in this way. Then we get x squared times dv over dx, which is 3, plus v 3x. Du over dx is same as 2x. Then we can say 3x squared plus 6x squared. So 9x squared is our derivative of the function y, right? That's how you do the product rule. So let's try, or let's apply this formula into the example. So example number 5. So we have f of x equals to x squared plus 3x times 2x minus 1. So again, I'm first going to set the first function as u and second function as v. And I can say it's u times v, right? So means I have to use the product rule. So now the first thing that you always have to do is finding the derivative of the each function. So we know that u is equal to x squared plus 3x. Du over dx is same as 2x plus 3. V is same as 2x minus 1. dv over dx is same as 2. Then we recombine this together. So using the product rule, I know that f of x is same as u times dv over dx plus v times du over dx. So recombining these four will give us x squared plus 3x times 2 plus 2x minus 1, 2x plus 3. Then expanding all these terms will give us 2x squared plus 6x plus 4x squared plus 6x minus 2x minus 3, and this is same as 6x squared plus 10x because of this and minus 3. Okay, so we have found the derivative of the function f of x. Let's do example 6. So example 6, we have h of x and we have two functions again multiplied together. So x squared and the sine x. We can say x squared is u, sine x is v. Then we can say u is equal to x squared. Du over dx is same as 2x. V is sine x. dv over dx is cosine x. Then we can say h prime x is same as u times dv over dx plus v times du over dx. So this is same as x squared cosine x plus sine x times 2x, and this is equal to x squared times cosine x plus 2x times sine x. So now let's talk about the quotient rule. So quotient rule involves with a function that has a within the function, it actually has two functions, and then one function is divided by another function. So when we have cases like that, we have to use the quotient rule. And I also sometimes call the quotient rule as a division rule. This is my thing. The only reason why I do that is we use a function that has function divided by another function within it. Okay, so let's talk about the rules. Okay, so the one on the right hand side again is in your formula booklet. Okay, and I also included a simplified version on the left hand side. So Let's say we have function y, and if this function has a uh, like fraction and has a numerator and a denominator like this, then in that case, if we have a function divided by another function, like in this case, we say we have to use the quotient rule. Okay, in order to use the quotient rule, you need to find the derivative of the each numerator and denominator. So f of x, f prime x, g of x, and g prime x. After that, you need to recombine them. So g of x times f prime x minus f of x, g prime x over g of x squared. You can also say that numerator is u, denominator is v, and then find the derivative of the u and v like this, and then you can recombine them like this. Yeah, or also use a dip notations such as du over dx or dv over dx. So let's do example number 7. Again, like working with the examples or the problems is actually going to help you to understand the formula way better than just looking at the formula. So when you look at example number 7, we have g of x equals to 5x minus 1 over 3x squared. So I'm going to set 5x minus 1 as u, 3x squared as v. Then u is equal to 5x minus 1. U prime or du over dx is same as 5. V is 3x squared. B prime or dv over dx is same as 6x. Then when we recombine this using the quotient rule, we can say the g prime x or derivative of function g of x is same as v times du over dx minus u times dv over dx over v squared. Then we get 3x squared times 5 minus 5x minus 1 times 6x over 3x squared and square. Then we can expand all of this. Then we get 5x squared minus 30x squared plus 6x over 9x to the power 4. Then this is same as negative 15x squared plus 6x over 9x to the power 4. Then you can see that all of them, all three terms has common factor 3x. Then we can simplify this further as 3x times negative 5x plus 2 over 3x cubed. Then we can simplify this, and it's same as negative 5x plus 2 over 3x to the power cube. Okay. Then let's try the example 8. Again, I'm going to say 3x minus 2 over 2x minus 5. I'm going to say this again, like if you feel like you want to try the question first, then stop the video, try the question, and then go over the solution with me. Okay? So I'm first going to set the numerator as u, denominator as a v. Then u is equal to 3x minus 2. U prime is same as 3. V is same as 2x minus 5. B prime is same as 2. Then we can say dy over dx, derivative of the function y, is same as v times du over dx minus u times du dv over x dx over v squared. Then this is same as 2x minus 5 times 3 minus 3x minus 2 times 2 over 2x minus 5 squared. Then we get 6x minus 15 minus 6x plus 4 over 2x minus 5 squared. Then you guys get 6x minus 6x simplified. Then we get negative 15 plus 4, so negative 11 over 2x minus 5 to the power of 2. And that's your answer. Okay, so now let's talk about the chain rule. Chain rule is one that has the a function inside a function. So means it is a composite function. So it involves with the composite function. We have the formula for the chain rule in your formula booklet, which is this one. And when you look at this, it doesn't really make sense because it says like dy over dx is equal to dy over du times du over dx. So if I put this again into a familiar format that involves the function f and the function g, then it looks like this. So I'm going to explain you what this means. Okay, so this is same as like function inside of the function, right? F of g of x. And when we have this, what we need to do is we have to differentiate the outer function first. And when we do that, we don't touch inside. However, once you done with the differentiating the outer function, you take inside and differentiate it. Then you can find the derivative of a composite function. So let's do another one example. Okay, so let's say we have y equals x squared minus 3x to the power of 3. So in this case, we can say that there is outer function, which is the bracket square bracket cube, and there's an inside function, which is a x squared minus 3x. Then we can say that y prime is same as, so we differentiate the outer function first. So we do 3 times x squared minus 3x to the power of 3 minus 1 times, and you take inside and then differentiate it. So it becomes 2x minus 3. Then your final answer, the y prime is same as 3 times x squared minus 3x to the power of 2 times 2x minus 3. Then let's do example 9. So when you look at example 9, we have a y equals cosine 3x. We need to find the dy over dx. So you can say the cosine is our outer function and 3x is our inside function. Then we can say dy over dx, when you differentiate the cosine x, it becomes the negative sine 3x, and we don't do anything about inside, right? Then you take the inside and differentiate it, so it becomes 3. So your final form is the negative 3 times sine 3x. Then let's look at example 10. We need to differentiate the function f of x. When you have radicals, I suggest you to change the format to the exponent form first. So this becomes f of x, 3x squared plus 5x to the power 1 over 2. Then you can clearly see that there is a function inside a function, right? So our outer function is a bracket 1 over 2. Our inside function is 3x plus 5x. Then we start with the outer function. So it's f prime x is same as 1 over 2, 3x squared plus 5x to the power of 1 over 2 minus 1 times, we take inside and differentiate it. So it becomes 6x plus 5, right? Then this is same as f prime x equals to 1 over 2, 3x squared plus 5x to the power of negative 1 over 2 times 6x plus 5. Okay? Then let's do example 11. We need to differentiate y equals sine square x and need to simplify. Again, y equals sine square x is same as sine x to the power of 2. And you can see that there's a function inside a function. So outer function, inside function. Then we do y prime is equal to 2 times sine x 2 minus 1. And we take inside and differentiate it. So sine, when you differentiate the sine x, it becomes cosine x. Then we have y prime equals to 2 times sine x times cosine x, which is a double angle formula. So we can simplify it into sine 2x.